Understand when and where these formula we need to use. Let me start with an example. If you are going to see the example number, I think it's, let me go to the page, sorry for that. This is example number 27 from the Giancoli book, in which a projectile is fired with a speed of 36.6. This is initial speed at angle of 42.2 degrees and above the horizontal. So the first question is find the maximum height reached by that projectile. To understand, I wrote the data that initial velocity and initial angle is given. To find is the vertical height, the maximum height. Actually, this is the maximum height. We sometimes say y, or we can also say ym. So no problem for that one. So then we will use either third equation which I wrote. So I just rearrange the third equation. If you remember, I wrote here was 2gy is equal to v square minus vy square minus vy naught square. So this is just rearranged from vy naught is equal to this. So this equation we are going to use. So when we use this equation, we need to keep it in our mind. Very important thing that a projectile, whenever it where it is maximum height, its vy will be 0. Vy naught can be found by v naught sine theta, and initial position y is 0. We don't need to consider it. So substituting the values here, I substitute vy is equal to 0, vy naught v naught sine theta, and 2gy. But here I change the sign from positive to negative because of the g, as velocity vy is going up and acceleration is going down. So for that purpose, g and v are in opposite direction and it's slowing down, so g will be negative. So I substitute it here negative, or you can just simply keep it plus and then negative 9.8. So the values 36.6 for v naught, angle 42, negative 2 times 9.8 ym. So I just rearrange it here, and I rearrange it. So negative 2.2 into 9.8 y becomes positive, and this is multiplied, and on the other side we will divide it. When we divide it, so the simplification gives me answer of 30.8 meters. Similarly, the second part of the question is the total time taken in the air. So we are now going to find the total time, but keep it in your mind to find the total. And now you have ym 30.8, approximately 31 meter. The given data is same, initial velocity and theta are given. Time to find, for the time I can use second equation, y is equal to vy naught t plus half gt square, substituting the same values, but keep it in your mind that vy is 0, and the y naught is also vertical. So we don't need to consider this because I am not using this one in the equation. So vy can be v naught sine theta, and initial position is y naught is equal to this. So this one, this one we need to use it. Why? Because when we are starting, so you need to find the displacement. Displacement is we are going up and down. So when the flight will cover total time, for example, this is your projectile, and projectile is moving from ground to ground. So the displacement from the ground to ground, that's why we will put y is equal to 0. So y is equal to 0, and the rest values we will keep the same. Substituting the values, I change to 0 is equal to v naught sine theta t plus half g t square. G is negative 9.8, so sine changes to negative half into 9.8 t square. So when I substitute these values and simplified it, what I got, the time is 5.02 seconds. That is time for the total flight. We can also use time for the half flight, and then we can convert it. For example, we can use alternative method here. So alternatively, what we can